All right, so this is the first lesson on properties of logarithms. And so for 5.3, properties of logarithms, we are going to go a little bit beyond logarithmic functions, and we're going to go a little bit more into, you could consider it to be more pure algebra. So we're going to get a little bit more abstract in this particular lesson, and it will really seem abstract in the beginning before you start to really get used to the notation and the rules and the properties of logarithms that follow from their original definitions. So let's just take a quick look here. Logarithmic notation. It's simply a way of writing and representing exponents of a particular base with a particular desired value for the output of the corresponding exponential term. So that is definitely a mouthful. It's probably not necessarily the most the clearest wording, although it is true and it is the definition of a logarithm. So before I read this sentence as well, let's take a look at log, something like some term like log base c of x, and we could say that this is just going to be equal to some value that we don't know, so let's just name it. We'll call it y, right? And what we can do here is we can rewrite this equation in logarithmic form to exponential form. So this statement really just says base c raised to some power y equals x. So base c raised to some power y is equal to x. So this is the exponential form of this logarithmic statement. But what I want to get you used to seeing is of course, I want to get you used to understanding the relationship, the equivalence between these two statements. But I also want to get you used to seeing something like this. C raised to some other power. It's not technically true to call it some other power, but c raised to some equivalent power, just written in some other form, is also equal to x. So how else could we write this exponential form of this logarithmic statement? Well, we know that log base c of x simply represents so this logarithmic term simply represents the exponent that we would place on base c to get x. So we can write this as c to the power y, whatever we symbolize as the answer to log base c of x, or we could represent this as c to the power of, and here's the jump, log base c of x, and that would be equal to x. So eventually, what you should be able to do is you should be able to see an equation like this as somehow naturally true. Right? This is a natural consequence of our definition of a logarithm, right? The logarithmic term itself is an exponent, and so why not write it as an exponent? And this is really the logarithmic property that I start to explain here. Now let's say that was confusing and too big of a jump. I can prove it a little bit more trivially here. So one thing that we know is true is that log base c of x is equal to log base c of x. This is a very trivial statement, right? This logarithmic term is equal to itself. Right? I just rewrote the same thing on the right-hand side. It's like saying 2 is equal to 2, right? Now, let's start to play with this statement a little bit. We could write this as c, base c, to the power of log base c of x should be equal to the input of that logarithm on the left-hand side, right? So from this sort of trivial statement, we can see maybe more clearly why this relationship is true. And that's explained here. So the term log base c of x is simply a particular exponent on base c, such that when c is raised to the power of log base c of x, we just get the value of x, right? We get the input of that logarithm. And then I simply restate what I have written on the right here with this statement. And let's look at some more basic rules for logarithms here. So we've already found c to the power log base c of x is just x. What about log base c of c to the power x? Well, here we can ask the question, c raised to what power would give us a result of c to the power of x? Well, c raised to the power x would give us c to the x. Hopefully that makes sense. C raised to the power of x would give us c to the power of x. So x would satisfy this equation here. So log base c of c to the power of x is just x. And these two on the right here I would classify as maybe easier to understand. These two right here I would say are easier to understand than these two on the left. I actually want to look at this a little bit more here. Let's test whether or not we see this as true. Let's test whether or not we can make sense of this. Let's rewrite this logarithmic equation in exponential form, and we're going to see if we get a statement that makes sense here. So, rewriting this in exponential form, we can write base c to the power x is equal to the input of the logarithm, which is c to the power of x. Now, if you don't think this is true, well, hopefully you do. Hopefully you do think this is true. Hopefully you do think that c to the power of x is really equal to itself. And that's all I'll say about that. So hopefully that's convincing. So there's another basic property of logarithms. Now let's look at these two, what I've claimed to be are easier to understand. We can say c raised to some power equals 1. Well, c raised to what exponent would be 1? Well, c to the power of 0 would be equal to 1. Let's check and see if this makes sense. C raised to the power 0, is that equal to 1? Absolutely, right? I almost said by definition, but there is a logic to this. And of course, I didn't write this in the notes, but this is contingent upon c not being equal to 0, although we do assume that for all logarithms that we define here, we do assume that we aren't taking 1 as a base, and we do assume that the base is positive. All right, so let's look at this last basic property of logarithms. C to some power, c raised to some power, is equal to itself. Well, what power could we raise c to get itself? We could raise it to the power 1, right? If we rewrite this in exponential form, c to the power 1 equals c, is that true? Absolutely, that is true, right? Absolutely, that is true. All right, so these are the basic properties of logarithms. And because log base c is simply an exponent, and because all of these sort of more basic rules are true, we will notice certain other properties of logarithms that can ultimately be derived from exponent properties. For example, if we apply the product rule for exponents, right, c to the x times c to the y equals c to the x plus y, if we apply this product rule for exponents, then this allows us to derive a corresponding product rule for logarithms. This is the corresponding product rule for logarithms. Log base c of x times y is equal to log base c of x plus log base c of y. And in the next video, I will take you through an explanation of why exactly that's true and how exactly that property of logarithms, that product rule for logarithms, follows from the product rule for exponents. And I will see you then.